Hello and welcome back. Okay, so in this video I'm going to do what I've promised to do for a while, and that's convert all of the pipeline here to PCBs. Now previously in PCB videos I've done various splits between the various elements of making PCBs. On the first of the address registers I did the schematic, the PCB layout and the soldering in separate videos. More recently I've done all of the design work all the way through to installing it into the build all in one video. But I think for the pipeline I've looked at various ways of dividing up the work, maybe doing one pipeline stage at a time in the same vein as I've done the later PCBs over here. And that's not really going to work for me because there's a big imbalance in the different sections of the pipeline. So I'm going to do all of the PCB design in this video and then we'll do all the soldering later on. So we've got three pipeline stages. You've got stage 0, which is fetch, stage 1 and stage 2. Fetch pulls in an instruction from memory every cycle that one of the other stages isn't accessing memory. And then the two further pipeline stages are just issuing commands to the various buses, ALU, memory subsystem in order to perform the functions of the processor. These two pipeline stages are almost identical in terms of their underlying circuitry. They have the same main inputs, which are the flags coming out of the ALU and a couple of control lines. And then they each have 16 outputs that are going off to various other sections of the processor. Each of those outputs are different, so we'll need to redefine those. In video 72, the fetch unit gained the capability of handling an instruction sequence that was previously invalid. So you've got two pipeline stages, and in pipeline stage 2, regular memory access is mediated. And in pipeline stage 1, it has the option of reading in an extra byte of data from the instruction stream to handle immediate constants. But if you have both of those executing at the same time, it doesn't work. The immediate doesn't get read. And so we added the functionality to both detect that and handle it by redispatching the immediate load that's been held in the latch chip here. Now the one thing we didn't do is add anything to pipeline stage 1 to prevent that instruction. And so I would like to add that functionality, but I'm going to do it straight into the PCB design. That may be asking for trouble, but there's just no room here to try and do it without a radical rework of the existing breadboards. And this is getting pretty packed as it is. In the corner of this PCB, I've got the original reset circuit that mostly just clocks the pipeline several times during the reset and forces the fetch unit to output NOPs, and so that just flushes out all the contents of the pipeline. Now we worked out a slightly different way of doing that with the new clock and reset circuit, but if I convert all of this to PCBs as is, it kind of relies on adding that functionality. So when it comes to testing out the new PCBs, we'll have to work out how to deal with that. Okay, let's get to it. Right, here's the back plane as it currently stands. Now I've got a crazy idea. I want to build the new elements of the back plane on to this schematic and PCB, then cut all the rest of it off and route it, but then I'll have still a file for the whole great big back of it. So if I just get a strip done with the new bits on, I can cross-connect them and hopefully get that made and use it as the basis for assembling the remainder of the CPU. Only at the end will I try and put together a plane for the entire thing. Now the pipeline steps are going to be 3 horizontal PCBs. It would be kind of nice if there was some symmetry with the pipeline. So if they could be this tall, same as a register, that would be good. So each of the pipeline stages will have 8-bit input and 8-bit output. In the fetch unit, this will be memory bus. Basically, at each stage, this is passing up the instruction. I have 16 control lines out. I think that's all the wires it needs. Now the idea here is to create the wires for all 3 pipeline stages and then just chop the ones that aren't needed or leave them unconnected. was hoping there was going to be a way of constructing the basic outline and then kind of placing them into the backplane. There must be a way of doing that. So we need the two ROM chips, we need a latch chip to hold the current instruction in. Now we're going to need some line drivers. We're also going to need a bunch of LEDs and resistors. I'll use those new resistor arrays for the LED driving, so they won't take up much space. Actually, we had 574s to buffer the outputs as well. I can get away with just the two. These outputs actually have to get buffered through. Since these are sockets, we can put the caps underneath the chip, which is actually a really good place for it. Okay, now that is a really tight squeeze, but I reckon we can route that. We need 16 LEDs for the control out, 8 for the instruction, and we did talk about a version of the pipeline stage 1 which clamps its output if we've got the bus request and the fetch suppress active. So we'd need an AND gate and 2 selector chips for that. Let's see if we can fit those in. Right, so these are all the outputs. Can we get that a bit closer? Maybe. Okay, starting to feel like I need to add the LEDs in just to be sure. Let's do that. I have realised that these chips are going to need a clock signal and I haven't brought that in. Alright, can I make this any smaller? That makes a lot of sense. I'm not going to make it any easier to route though. Now I had thought I'd just lay out the chips to work out roughly the size and proportions and where the inputs and outputs were. I think I actually need to build more of the schematic here to be sure it's going to work. This is really tight. This wiring's actually wrong because I've got to go via the selectors in the non-trivial case. I think I would be smart to spread this all out a little bit more. Now this chip has 4 identical selectors on it, but I'm purely worrying about which order I use them in just to try and make my life a little bit easier on the routing. Now I'm merely looking to zero out the outputs. I'm just doubting whether or not the selectors are the right way to go. Yeah, if I use an AND gate and wire all the B channels together, that'll work just as well, but it'll be a smaller footprint. Can't forget this is inverted from what I was planning, so let's call this pass out. Yeah, this just feels way too cramped to me. I like this, it's going to give me a bit more room to do some decent LEDs. I want to get some labelling on what the different control lines out are actually doing. Right, so the bottom 8 bits of the address on the ROM is the instruction. Now we take that from the input, which might seem counterintuitive, but we latch the outputs and that removes the latency of the ROM lookup. This would potentially be easier to route without the resistor arrays. I haven't got space to put traces in between the pads on these things. I think it will be better to have the resistors on the other side. So I want to swap these two over. And I need to swap the other pair as well. Okay, well I think this bit over here is routed okay. Okay, the positioning of these is going to depend on how closely I can pack these wires together. It's nice to have all the space up here because I can do nice little clusterings of the LEDs. This is a pipeline CPU after all, so I want to be able to show what's happening. Okay, renaming all the control lines to be the actual functions that they perform rather than just numbered 0 to 15 is going to help configure them later. And then clustering up the LEDs so we can label them and reference the functions. It's going to make it a lot easier to identify what's going on in the processor. These are the instruction inputs into the ROMs. They were particularly difficult on the breadboards, but fortunately I can do this once on pipeline stage 1 and then copy it to pipeline stage 2. Same applies to all of these other cross connections. Most of the inputs between these ROMs are completely shared. These are the outputs going into the latch chip. On the breadboard, all of the clocks are driven from the same line in the entire pipeline, but we're right close to the fan-out limit for that signal. So a clock goes into 3 devices here. We've got NAND gates here that are unused. If we connect the inputs of an AND gate together, it becomes an inverter. And if we stick 2 inverters in series, it becomes a buffer, albeit with a small delay. Okay, that's giving me a complaint that those 2 are cross-connected. I think for now we just drop that from there completely. I may drop the size of this. Okay, getting power across here could be tricky. In fact, all the signals here are best placed elsewhere. I'm just going to move it. Yeah, that looks workable. Alright, is it worth me changing this? No, it should be nice to keep it consistent. Electrically, I think that's complete now. I've got a decent amount of space for the labelling. I'm hoping these are going to sit comfortably under the sockets, but I do need to check that before I order this. Right, lots of labelling and prettifying now. On a couple of bigger capacitors there. Now this header I'm kind of just including to provide a little bit of physical support at the bottom of the board. I think I'm going to put power into there as well. Okay, that wasn't in here last time. By changing a pin from ground to VCC, I seem to have messed up lots of traces. I'm not sure if there's a nice easy way to fix them all. I'm going to start with a copy of stage 1. Okay, that was easy. Now, big difference between these two is is not necessary. We probably still want to buffer the clock like that, so we'll keep those. I'm going to get rid of these copper areas because they just get in the way while you're trying to design stuff. So it's U12 and U11 aren't needed anymore. Okay, what's frustrating here is all of these components at the moment are an exact match for pipeline stage 1, but the LEDs are going to end up in different locations just because of some slightly different groupings. I could try and reuse the stencil, or I could make this less cramped and accept I'm replacing it. Okay, so that's the first 4 lines. So next for a load. Okay, so the first 2 bits are increment. So we've got 3 bits which are the address output. This is controlling which register is currently being pushed out onto the address bus. Bus request, PCRA flip-flop. That one feels slightly weird to me because I haven't done the circuit for it, but I'm expecting to have done the circuit that this connects to by the time you see this as a recording. So it's address select, then we've got bus request. Okay, I've misaligned all this. So that's the increment, it's the address select. Then we've got 3 singles. Yeah, that'll do. Right, now if I'm not mistaken, that should be done. Okay, so let's get the copper areas back in. These are the wrong way around. That would have been slightly embarrassing if I didn't spot that. Where doesn't it go? I'm going to always rebuild the copper areas just because I don't want any surprises if I load it in the future and it rebuilds. Okay, now for the fetch unit, I've cloned pipeline stage 0 just to get the rough PCB dimensions because I want the width to be the same and I want the positioning of the inputs and outputs to roughly line up. We're probably going to make the height different because there's going to be less work on here. No need for these ROM chips. Right, so the main input here is actually mem data. It'd be nice to just switch those labels over. Now we're going to have far fewer outputs than this, but we'll leave that how it is for now. Right, so we definitely want this 574. Only the inputs are whatever's on mem data. And then we need some 153s. Okay, so these enable inputs need to get pulled down to ground. It's going to be easiest if we get all of this stuff right before we copy it out. The middle two inputs for each of these needs to be ground as well. Those are our generated NOPs. Right, so lowest input will be mem datas. Highest output will be the latched instruction from the last feed. We've only got a single use for the clock on this board. So there's no reason why we can't just put the clock into it. We can get rid of that. We need 4 of these. Go through and update all of these numbers. I can actually only think of 2 output lines from the fetch unit, and they're driving the incrementing for the program counter and return address. Now what's a complicating factor here is these are directly resolved from the inputs. See what it complains about. All of these have to go. Now, actually I don't like this. This means the inputs are going to be asked to drive an extra set of LEDs. Okay, so we're passing this through 2 inverters and that will buffer it. I'm kind of surprised there doesn't seem to be a 7.4 series chip which is just a buffer. I'm happy doing this though because I know I've already ordered a bunch of 04s. So it's U3, U19, U8 and 20. Nothing up here to support the PCB. A lot of my design decisions here are being heavily influenced by what I did for the next 2 pipeline stages. That is lots more satisfactory. So these line up with the least significant bits on the other 2 pipeline outputs for both the LEDs and the output lines. And the flags and all the other ones appropriately match. should look okay sat next to them. Right, I believe that's the schematic for the fetch unit done. I've got 4 of these on this board and I'm kind of stuck with this, trying to lay it out with a longer profile. But this would be a lot easier with a different orientation of the chips if I stack them vertically. Now in the ALU I've got 4 of these in the shift unit and 8 in the logic. So I think in the ALU we want to get these vertically arranged. It's going to make life a lot easier there. This is a pain, but it's doable. Okay, so this is the big back plane that exists behind the register stack, and I want to extend this to have the componentry of the pipeline on it. Now, rather than measure everything carefully, I think what I want to do is just grab what I need relatively. I need to import these connectors as well. Now we might run into problems where some things had the same name between pipeline stage 1 and pipeline stage 2 because it's a copy, but we'll deal with that if it does happen. So this is okay. That's not right though. So these should be independent of one another. And finally we can see how big the pipeline is going to be in the main build. Looks fairly reasonable. I'm hoping I can fit the ALU into this space here and then leave the size of the memory unit at the bottom for the new clock. Feels about the right size. Don't know if I can fit the ALU in there though. Right, mem data has lined up correctly. Output 3, input 2. Okay, so now all I have to worry about is all the intricate connections between here and here. Right, so LHS and RHS, ALU operation, they don't exist yet. Sheer bulk of wires that we're going to be removing from the build when this goes live. Really quite cool. So these are address bus selection, determine what register is outputting to the address bus. We have the origin of the bus request line and PCRA flip. Now break is interesting because that doesn't currently exist. I think for the schematic we're done. So obviously I won't want that in the final build, nor will I want all of these along the bottom. These are temporary inputs that are connecting up to other sections. In the final build this will just wire into this when we route it, but for now we'll be running a cable from here to join mem data up, and then all of these various inputs are there for cross-wiring everything between the pipeline and the remaining chunks of hardware. This output is effectively the connection that would go on to a third pipeline stage, which we're never going to have. But I quite wanted to put this as an out, just in case I ever want to build some debug circuitry to monitor what's popping out the top of the pipeline. Don't want these copper fills for now. Now what I'm doing here is removing everything we don't need. So it's 15 and 16 are the ones we want to keep. So, device assert entries, all of these mem ones. Right, that has the makings of a nice PCB. See what nets it's complaining about. Clock in and reset in. Probably going to have to manually cross-connect those, but that looks perfectly workable to me. Stick a ground plane in there. That, I think, is a workable back plane. Now I'm going to get this done in green. Wish there was an option to just do one or two. Let's order one of these up. Now I've got one last thing that I think might be quite clever to try. All of these connections to connect between the original backplane and the new one. I mean, these have got to go as well, but these are right next to where they need to go. And rather than have a bunch of short ribbon cables, I'm going to see if I can make a custom PCB for that. Now, I may want to reconnect to them. So let's put 3 lots of these on. This just cross connects all of these. So if I solder pins into the left and the right hand side ones and then just drop this little PCB in between the 2 back planes, it will make all of those connections. And then for inputs here and any of the others I end up wanting to connect to otherwise, I can just wire some additional pins in the top here. So it's going to cost me $2 to save me a whole bunch of wiring. Totally worth it. And here it is. Not quite my biggest PCB delivery because the back plane was a larger container, but I think this is more PCBs than I've ever had delivered at once before. Okay, I've never had a coloured box off JLC before. I don't know if that's a new thing or whether or not it's just this form factor of box, which is different than I've received before. Okay, I must have put the dimensions in wrong on this one, or on these. Yeah, this one is randomly larger than other stencils I've had done. Although these are actually quite close to the edge. We can deal with that though. A lot of these components are in exactly the same place, but it's the LEDs and the extra components here on pipeline stage 1 which meant I needed different stencils. That is beautiful. Here's the back plane. Stage 1. And fetch. Right, so this is the main back plane that sits behind all the registers and the memory. So this will sit right there. Now I actually quite like the idea of the pipeline being lowered down, then having the ALU up the top and the clock at the bottom, assuming I can fit all of that in. But my final intention is to get all of the PCBs working and then make one big Uber back plane that's going to replace some separate sectional back planes. So at the moment there's lots of cross connections, so mem data will need to have a flying cable down to here. Although all these cross connections between these sections will get handled quite nicely by this. There's going to be a small gap there like that. And that should actually make this reasonably rigid as well. A connector to go across there. Maybe actually make one with a little bit of strip board. That's probably the right thing to do actually. That's good. That way up. So this is just temporary while I have these bits of backplane separate. Okay, well I am really pleased with this. These boards look great. I'm very keen to get these soldered up. What I need to do now is go through and check that I've got all the parts. I think I do, but using the stencils I need to make sure I've got them all before I do it, and I'm going to start soldering these as soon as I can. So, I hope you found this interesting. Thanks a lot for watching, and hopefully I'll be back with the soldering video fairly soon. Thanks for watching. Goodbye.